Hey guys, welcome to Unit 9, Lesson 8. This is the last lesson for this unit. For the warm-up, you can use the calculator, pause the video and try it. The warm-up says the horizontal position of a particle moving on the line y equals 2 is given by x of t equals 2t cubed minus 13t squared plus 22t minus 5, where t is time in seconds. So again, we are given an equation and it is a position equation and we want to find the rest of these things. I want to cross out F, we're not doing that. So A says describe the motion of the particle for time greater than or equal to 0. So whenever we talk about motion, we're talking about when is the particle at rest, moving right and left. So these are the three things. But when it's at rest is when your velocity is equal to 0, it's moving right when velocity is greater than 0 and moving left when velocity is less than 0. But be careful, we are not given the velocity equation, we're given the position. So how do we find our velocity from our position? Velocity is basically the first derivative of our position. So we're going to find the first derivative. I'm going to actually do it here. So derivative of v of t, I'm going to write that. V of t is derivative of 2t cubed using the power rule will be what? 6t squared minus 13t squared becomes 26t plus 22, right? And derivative of 5 is 0. So that is what our v of t is. We're going to set it equal to 0. So v of t is equal to 6t squared minus 26t plus 22 equal to 0. And I can't really factor it, so use the calculator. So we get t equals 1.153 and t equals 3.180. So it is at rest at these 2 points. Now it is moving. I'm going to use the number line to find out when is it moving right and left. So it's starting at 0 and the other number I'm going to place on it is 1.153 and 3.180. So I'm going to pick a number from each interval and substitute into my velocity equation because this is my velocity number line, and see whether I get a positive or a negative number for my answer. So between 0 and 1.153, I think 1 is a good number. If I substitute in 1, I end up with a positive number. Between 1.153 and 3.180, I'll pick 2. You can use the calculator too, guys. So you can avoid that unnecessary work in your head. So this would be actually a negative number. And if I pick a number greater than 3.180, I picked 4, which comes out to be a positive number. So basically it's moving right over this interval. So moving right, I'm just going to write it here also. When velocity is greater than 0, it is moving right from 0 to 1.153, and the other interval is 3.180 to infinity. Moving left is when velocity is less than 0, which is over this interval. Again, we're rounding everything to 3 decimal places. Remember, in this class we always round to 3 decimal places, so we should, otherwise you end up losing points. So please don't make that silly mistake. Okay, part B. When does the particle speed up or slow down? So a particle speeds up is when we compare velocity and acceleration. So I already know my velocity. Can I find my acceleration? So my relationship between acceleration and velocity is acceleration is the first derivative of velocity. So I'm going to take the derivative of my velocity equation. So derivative of 6t squared is 12t minus 26, right? I'm going to set it equal to 0. Solve for t. I get 26 over 12 or 13 over 6, right? So now it's speeding up or slowing down is when your velocity and speeding up is when velocity and acceleration both have the same signs. So let's write that down. Speed up, velocity and acceleration have same signs. Slow down, velocity and acceleration have opposite signs. So let's draw the acceleration number line. I'm going to just draw it here. I'm going to cap it off at 0, right? And my other number that's going to go here is 13/6, or I can even choose to write 2.167, right? So if I pick a number between 0 and 13.6, or 0 and 2.167, I picked 1, I get a negative number. If I pick a number greater than 2.167, I end up with a positive number. So it's negative all along here, and it's positive here. And this is my acceleration number line. So I want to compare them. If I was to compare them, look here, that's why I placed them underneath. From 0 to 1.153, acceleration and velocity have opposite signs. So I'm going to write here, speed up, slow down. So it's slowing, since it has opposite signs, so from 0 to 1.153, it's slowing down. From 1.153, if I was to draw a straight line right across through, right, it is what? To 2.67, it is what? Negative. So in this region, it is negative. They both have the same signs, meaning what? That it is speeding up. So from 1.153 to 2.167, we are speeding up. Then after 2.167 to 3.180, they again have opposite signs. So we are again slowing down. So 2.167 to 3.180, we're slowing down. And after 3.180, they both have same signs. They're both positive. So it's going to be 3.180, comma, infinity. Okay, so that was slowing down and speeding up. Part C. When does the particle change direction? So the particle changes direction whenever it changes what? Sign. When v of t changes sign. Right, so I already had my v of t number line. I'm going to just sketch it here again. And this was 0, and then the other critical value was 1.153 and 3.180, and it was going from positive to negative to positive. Not always will it go from positive, negative to positive. Sometimes it chooses not to switch signs, so you must always check in each interval. Okay, so it is actually in fact changing signs here. So the particle is changing direction at t equals 1.153 and t equals 3.180. Okay, so the next one, D, is it's asking us, when is the particle at rest? We already talked about it in part A. So it is at rest when v of t is equal to 0, which is the same answer as C, which is t equals 1.153, and the whole idea here is that you can get the same, the answer is the same, it is different ways of asking it. So I can either directly ask you where is the particle at rest, or I can ask you describe the motion. Then you're talking about rest, moving right, moving left. So it all is just, you have to know how to read it and answer the question. And the last one is E. Describe the velocity and speed of the particle. Speed we already talked about in part B. Velocity, how do we talk about velocity? Velocity has to do with acceleration. Wherever acceleration has a positive slope, or wherever acceleration is positive, v of velocity is increasing. So, and let's write that down. Wherever acceleration is positive, velocity is increasing. Wherever acceleration is negative, which is less than 0, velocity is decreasing. Right? So let's look at it. So it's going to be from, velocity is increasing from 13/6, or I use 2.167. I'm going to use 2.167. 2.167 to infinity, and it's decreasing from 0 to 2.167, right? And then our next thing is speeding up. I'm just going to copy the same thing from part C. It's speeding up at two intervals, 1.153 and 2.167 and 3.180 to infinity, and slowing down from 0 to 1.153 and 2.167 to 3.18. Oops, it won't let me write on the side here. Let me zoom out. .1, what was it? 180. Right? So that's it. So basically there was nothing new in this lesson. It was more of a practice lesson for you guys. So finish up the remaining 2 questions and reach out to me if you have any questions. Good luck, guys.